Okay, so I guess it's time to start. So before we begin, I guess I'll do what every presenter does and say, can you scoot in? I was a college professor for 4 years. I hated it when my classes spread out. So if you want to come closer, I won't spit, yell, or bite. And then also this whole talk, just to kind of preface it, is I've got slides that show you. They're useful. They may not be useful. I hope they're useful, but at the same time, it is a conversation. So, feel free to interrupt me, ask questions. I'm willing to talk through or share why any decisions were made on what I'm going to talk about. So, my title is Zero to Jenkins, Tips and Tricks for Using Jenkins in AWS. I'm the AWS architect for WatchGuard Technologies, and I also lead the infrastructure and DevOps team. So we do have a DevOps team. We're effectively a tooling team. So we manage the build systems. We manage Artifactory. We manage all that stuff, GitHub. We also provision all of the account. So all of our AWS accounts, all of our AWS services, the core services my team provisions and owns. And then we effectively re-offer those provision services back to our developers as a service to then attach microservices and things of that sort. And I work for WatchGuard Technologies. Has anybody heard of WatchGuard Technologies? So we make bright red firewalls. Okay, we're a hardware company. So here's just the obligatory, here's my company slide. So the mission of WatchGuard is to bring enterprise security to everybody, right? We make small, low-cost devices. We make large data center scale devices. We support HA. We support single configuration. We support one user. We support thousands of users. And so we really try to do this. Last year was our 25th anniversary. So WatchGuard's been around for a while. We're based in Seattle, so I'm from Seattle. We delightfully look into CenturyLink Field and get to watch the Seahawks from our office windows. I'm a huge Seahawks fan. We do have operating in a few countries, so we do have offices in Chengdu, China for our hardware division. We do have Toronto, Baltimore, and we just bought a company in Brazil, so we now have an office in Brazil. And then there's some information about WatchGuard. I myself work on WatchGuard Cloud, so I don't actually do hardware. I don't do embedded systems. I do cloud technologies. And so I work on WatchGuard Cloud, and WatchGuard Cloud is a new product offering coming out from WatchGuard to provide, that next-gen threat capability, reporting, any other type of security service you want, right? I mean, if we can integrate it into this appliance that you have on the edge, we'll try to do it. And so this is the team I work for, more specifically at the infrastructure and DevOps level. A little bit about me. So I'm not a developer by trade. Well, I guess I technically am because I did physical chemistry, but I have a master's degree in physical chemistry, so I'm a chemist. I did theoretical chemistry through all of grad school, and then I decided I hated chemistry. So I got out of grad school, and I went into computers, because I liked the technology side of it, got really tired of studying the chemistry side of it. I've been working with AWS for 5+ years in different, styles. 4 years as an IT consultant, so helping bring companies to Amazon, both from your traditional enterprise lift and shift of Active Directory networks to helping architect and map best practices for bringing on applications. I've been with WatchGuard for about 1.5 years now, helping them build out their DevOps practice, their automation best practices, and then architecting the core cloud infrastructure there. And then if you ever want to get a hold of me, there you are. Okay. So this is kind of my agenda for this overview. And this is not to say this is the way to do anything. So I think that's what I want to preface for, first and foremost. This is just how we did it and what worked for us. And so I just kind of wanted to share that and say what that is. Another tenet that our team has really abided by is we've really worked to actually minimize plugins in Jenkins. Okay, so being a security company, we have to keep on top of security vulnerabilities. So the less stuff I have to monitor and patch and update and potentially break everything, the better for me. Okay, and so some of this stuff like automated agent creation, I know there are plugins that do that, but we wanted to figure out a way to do it the way we do stuff. Okay, to fit in with the way we do our deployments on Amazon, and things like that. I'll talk about shared Groovy libraries. That seems to be a hot topic this Jenkins world. I've seen a couple talks that talk about it. So talk about the Groovy libraries and how we set those up to really empower our developers to have common functionality, but also empower our team to be able to update less build files. We can update these central libraries and have it apply to everything. I'll talk about hybrid Jenkins files, and by that I really just mean, some methodologies and some tricks that we found of running Python scripts within Jenkins to do deployments, because anybody who's worked with AWS, the Boto 3 library is amazing, the Golang library is amazing, and so those are fun to work with. They're a lot easier. Our developers tend to know Python, and so it allowed them to quickly onboard deployment scripts. I'm thinking of that, so I'll talk about that. And then kind of the final two topics, which is going to be Jenkins and IAM. So I'll kind of share how we were able to achieve with Jenkins an AWS integration without burning a single credential into any system. And so we have no AWS credentials burned into our system. Auto key rotation is happening every time Jenkins runs. And then talk about pipeline and multi-branch pipeline for us and how we do. We're 100% pipeline. We have no freestyle jobs. We started as pipeline. And so, just kind of the tips and tricks we've had there, why we've chosen it, and then visibility that provides to developers. And then any questions. So automated agent creation. So in our case, we use Amazon ECS. Does everybody know what ECS is? It's the EC2 container service. So because of that, we wanted to deploy our Jenkins slaves like we do ECS, because that's what we're really good at doing, right? We deploy ECS every day. Our developers are dropping code to ECS, and we're building against that very frequently. So we wanted our slaves to do that. The other thing is we didn't want to have slaves made in our other accounts. So we have an account segregation where our developers live in one AWS account, QAs in one account, staging's in another account, and production's in a fourth account. And so because of that, we have a lot of accounts to manage. And so, we wanted to be able to provide kind of a methodology there. We also, again, as I said earlier, had this desire to minimize our dependence on any type of plugin, specifically plugins that will be touching AWS credentials or interacting with the AWS APIs in any way. We wanted automatic creation of the ECS cluster, right? So we wanted these ECS clusters to spin up, to have the networking rules in place so that they talked back over VPNs that we built through automation, and be able to bring those online. We wanted the automatic updates of Docker slaves so that QA team can control what these Docker slaves look like. And in our case, this is mostly for our QA team, for them to be able to load on new tooling and expose that. And the reason we do this is our QA subnetwork matches our production network, except for we added 2 extra subnets that allow QA to access all the APIs directly versus having to come through our proxy layers. And so it allows them to better test the code there. And so we automated, the slave deployment, which subnet they're deploying into. Are they going to deploy into a database subnet or the database QA subnet to test the databases? Our middlewares, we're all microservices, so test all our APIs, or to be able to deploy in our proxy layer and test our proxy, because in our QA environment, our proxy is locked down to VPN access only. And so to better do that. So this is kind of the process that we came up with. We are a huge CloudFormation fan. So those of you who know AWS, there is every deployment tool under the sun to use AWS. I'm not here to start a fight. Everybody's got their pluses and their minuses. We use CloudFormation. That's what we chose to use. We don't need to be cloud agnostic, so we don't care about Terraform or Ansible, or I don't have time to roll my own, and I don't really want to pay for somebody else to do it because I want to live on my stuff. So we effectively have built a way so that Jenkins deploys CloudFormation templates, which then deploy our ECS clusters, deploy all of our networking automation. I'm lucky that our company makes a firewall for Amazon, so I have firewalls to build VPNs for cross-region VPNs pretty quickly. Build those VPNs, bring up these Docker slaves, and then also adjusting networking rules so that that QA instance can only talk back out to our main Jenkins master that runs the jobs. And so we've done that, and we've done that all in Groovy. And so here's just kind of an example of the Groovy scripts here. And so we have 2 jobs that our QA team really kind of controls. The first one is actually the automation of the slave creation. both inside of Jenkins and then also the automation of building out the subnets within AWS. And then we also have a secondary job that I'll show on the next slide that will actually deploy the Docker instances. So really, once we've deployed these subnets the first time, this job tends to only run once per environment unless we tear it down and rebuild it. So here we kind of came up with two methods to create and add these slaves, or remove and add these slaves, and go through these. The reason I show this code is because it took us a while to figure this out. We did this last year when Jenkins was just hitting version 2, so it was a little bit more complicated then. I know that they've made it a lot more simple. But just to show you that you can do this, this code that deploys this is also checked into GitHub. And so we have full source control on it. We don't actually have this living statically in our Jenkins server. It's there. From there, we go to our slave or our agent creation. These are just Docker containers. Super easy to build Docker containers. I'm sure everybody's built Docker containers before. We have a small run script that we run at the end here. You see the entry point, reconnects it back to our root to Jenkins server. The ports are opened up as part of the initial step so that this ECS instance can talk back. It can only talk back, so we're not leaking any data from our middleware. It's still secured, still following similar networking policies, but is there. But more importantly, we've given our QA team the ability to change tooling. So as they were going through figuring out what tooling they wanted to use for API testing, they were able to build this and iterate quickly, run through Jenkins to build the slave, and then immediately trigger jobs on said slave. Okay. It also lets us distribute code to our QA environment because it's burned in to the Docker container. So all of we use Frisbee for all of our API testing. Part of this build downloads all the Frisbee scripts, burns them onto the Docker container. When they add more, they just rebuild the Docker container. The new scripts are available to them. They can then execute that through another Jenkins job that we have that runs those slaves. Okay, so that's kind of our methodology for automated agent creation. We really did this to really support the QA team. And provide that visibility while still really building a secure network. That's kind of the hard thing, I think, is on AWS, is if you don't build and test in a networking that's similar to what production is, it doesn't ever work out. Right? That's not just AWS. I'd say that's for everything. Right? So NACLs and security groups, to make sure those are all working correctly, both as QAs are testing the APIs and then as those containers are behaving. And so this allowed us to achieve that. The next thing to kind of talk about is our shared Groovy libraries. We love our shared Groovy library. He is our friend. We named him P-Funk because he's groovy. And so everybody in our team knows about P-Funk. But why do shared Groovy libraries? I'm sure people have talked about this today, but we share common commands. Our director is a huge fan of the dry principle, just keeping everything simple and not repeating yourself. It allows for complex commands to be maintained more simply in one place. So, just because you can write out a get clone command in Groovy doesn't mean it's a fun command to write and make sure it's running correctly. So we've abstracted that into an object that we can call through our shared library. More importantly, it simplified our Jenkins files. So we're now to the point to where a middleware Jenkins file looks the same across almost all of our middlewares, beyond some parameterization. So we've built all of our deploy scripts to be very agnostic to where they're going. We have Jenkins tell them where they're going, in the case of AWS, which regions or any type of variables that need to be seeded into it. It's easier to onboard new team members. My team a few months ago got a new team member, and with this, they were able to onboard a lot quickly, start writing Jenkins files. They're not learning Groovy or declarative pipeline. It wasn't out when we started doing this, but declarative pipeline, they're not having to ramp up on that. They're able to just start using these functions and learn it in tandem as actually being, able to support the dev teams. It's also easier to update functionality across all the files. So in our case, I think we're running 600 some odd jobs, and those also include our multi-branch pipelines. And so these things there's a lot of jobs running, okay, and they suck to update when we want to push out a new way to do something. And so with the shared library, we're able to achieve more consistently those updates, those new commands, specifically in linting tests, we can do different things with that, and so able to simplify that. Just to kind of go over a shared Groovy library, this is kind of the general folder structure. You have your classes there, variables and resources. I'm not going to go too deep into what each of these mean. It's all on the documentation site, but then there's just an example of some that we run. So we've really kind of categorized all our stuff by functionality, and then from functionality into a more refined realm. And so we have kind of our base service, our base functions we use for all of our microservices. So these are functions that we see across all of them. Helpers that we use for the AWS CLI, I'll show you an example of one of those a little bit later. Notifications, we do not use HipChat anymore, but we have notification libraries here. And in that case, we're wrapping the HTTP request plugin. So that is one plugin we do use, is the HTTP request. So we interact with all of our applications versus plugins through their actual APIs. We actually use MS Teams now, so we call back into our webhooks in order to notify build failures and so on. Our unit testing functionalities here, so the commands that we use for our unit testing. User functions, so we were able to figure out a way to parse the files and get the actual user who ran stuff, so we can tag AWS instances based off the executed user. And then some validation tools that we've written. Okay. And so we have all those in there. The other thing to keep in mind is my team does not use declarative pipeline. I don't actually know declarative pipeline. I haven't looked into it. I don't really care. We started with Groovy last year, and we're doing that. And so for us, it works for us. The similar thing can be done through declarative. We also store all of our Groovy libraries in GitHub. So we're, I guess, what's called scripted. And so all of our stuff's out. So the one thing to keep in mind is you do have to authorize some of these functions to deeper levels of Jenkins because they are outside of that. My team is the only team that can actually merge into any of the branches that Jenkins pulls in. So if developers want to add functionality, they have to go through a code review process through my team, so we test everything pretty heavily. And so we are able to comfortably whitelist the lower functionality if needed. Writing files, here's just an example of writing files. You declare information, create your method structs, et cetera, that are needed. And so in our case, they're simple as to just running the JUnit archiver to pull the data into Jenkins, right? It's a simple command. But the nice thing is we're able to add cleanups to these things. So a lot of times, people forget to clean up stuff, and Jenkins servers fill up. And it's never fun to have a full disk on a Jenkins server. It stops working. And so a lot of our stuff is so that we can add in extra functionality of, you generate all that data. Well, now we've ingested it into Jenkins, so we don't need the raw files anymore. And so we have a lot of cleanups. With a lot of our Docker commands, we then feed back in a Docker remove because we don't cache any images on our Jenkins server. We build everything from scratch just to make sure that everything's clean there. And then to leverage these, you can do things like this. So this is the checkout. So we do leave a lot of this information so we can feed in URLs as parameters and credentials as parameters for GitHub. And so we do have this checkout class that we leverage that allows us to easily check out. The other nice thing is we can change the formatting of this. So the Git one's fairly straightforward. It's not very complex there. But for more complex ones that you want to add more functionality as time goes on, you can adapt these and so on. And in our case, all of our deploy files actually have special endings to them, and they are named very similar to their regular deploy. And so one of the next steps we're working on is actually when you run a checkout, it checks out both repos at the same time so that way you don't have to run two checkout commands in the Jenkins file. You can actually do that. So depending on how you have your functionality set up, really depends on that. And then to add these is just very simple. It's in the Jenkins UI. Just here's a screenshot of it that I took. You add it in here. The nice thing is when declaring these things, you can set a default version, and then also in the declaration and the import, select a different branch within that. And so in this case, we default all our stuff to the master branch so that if anybody calls our library, it's the master branch. When we test our stuff, when we add changes, we then call in the dev branch or a specific users branch in order to bring those in, go through our testing. Then our QA person on our team will then also run through some jobs to test that before we actually merge. I think that's the other important fact is we treat pfunc as a developer would treat any type of microservice. We dev it, we QA it, we test it very heavily. In our case, we're still working on how do you unit test Groovy files comfortably, and what works for us. But we do test this stuff, and it does get promoted through code reviewed very regularly on that process. And then as far as usage goes, you just have your add import. In this case, we import pfunc. Jenkins will go check out pfunc, bring all those codes in, import it. We then import all of the different classes that we need, define them, and then can leverage them like we saw in the GitHub thing. Okay, so fairly straightforward here. For us, again, this is one of those things that's been fantastic to do, especially with AWS CLI. We do write a lot of wrappers around AWS CLI, which I'll show in the Jenkins and IAM on some things there. Okay. Hybrid Jenkinsfiles. So this is not meant to be anything fancy. It's literally just Jenkinsfiles that then run shell scripts onto other files. But just some things that we decided when going through this. So versus doing all of our deploy, which we do some of all of our deploys fully in Jenkins, they're a little bit more cumbersome than a lot of our Python stuff. But our big struggle has been our devs don't know Java. Okay, WatchGuard builds firewalls. We build embedded appliances. So everybody knows C. And then on top of that, we use Python because it compiles to C. So we know Python really well. We know Go. We have some developers that know Go. We have some that know Ruby. And so in that, we don't have a lot of Java developers. So when we started a year and a half ago, really trying to onboard this and onboard it quickly, we made a decision to run all of our deployments outside of the Groovy in Jenkins and actually run external scripting. Okay? And so what does that look like in a Groovy file? So here's an example of just one of our builds. This is a simple build. We have our checkout step. We clean all the directories before we run everything just to make sure nothing's there. We do some Angular builds, and we're running into weird artifacts with Angular. And due to that, we have a cleanup at the beginning. We check out the code. We build the code. In this case, we have two build stages. The first one just does a Docker build. The second one does the Docker push. And then we deploy. And in this case, we deploy our code using a Python run file that the developer controls. Okay. The big thing we do is we make sure every developer debug logs everything. So we try to collect as much data into Jenkins as possible. So when their stuff runs, you see this. So we debug out everything, try to collect that data. So even though Groovy is not natively running it, we're still collecting the data about what's going on there, what failures are happening from within those. Okay. All of our deployment scripts have been generalized, and we have Jenkins passing a lot of parameters. Since we multi-branch pipeline, all of our parameter configuration is all inside of our Jenkins files using the parameter pipeline stuff. And so we have that. We can also then parse the output from these scripts inside of Groovy. So like you can with anything in shell bash scripting, we can parse that stuff. The other thing this allows us to do is my team controls the Jenkins files. Okay, so because we are a security company and because Jenkins does all of our deployments, our team takes pretty tight reins on that. We let developers fork in stuff and review it, but our team manages that code repo. Because of that, in order to not slow down developers deploying code, right, we more care of did they build it, did they make sure all the testing was ran, nobody taking shortcuts. It allows them to write their own deployment files, so as they want to bring on new services and so on. And then we do gain access to more SDKs and stuff available. Yeah. Yes. So we have some checkers. So a lot of our, so I can take an aside. We actually block a lot of stuff at GitHub. So we use Jenkins calling GitHub status checks. And so we have some tooling that's like, our team builds ECS clusters, so we make sure they can't submit an ECS cluster. We control the IAMs, so they clone our IAMs down into their repos and deploy them, but our team manages them. They make requests against that. And so we make sure they don't have IAM. We make sure they merge in our merge process. So we have developers that try to circumvent dev a lot, so we block it now. Because we carry two folders, two repos for every microservice, a deploy and an application, We also have a GitHub check that goes and makes sure there's not a pull request open on their deployment code so that we don't break Jenkins. All that takes place in Jenkins. All that functionality actually has been generalized too into our Groovy files, and then inside of Jenkins, we even generalized it, so we're parsing parameters from GitHub in order to achieve all that. So we try to abide by those same methodologies through that. So the final thing, this is probably the thing I'm the most passionate about and most happy with what we were able to achieve, is Jenkins and IAM. I like to brag that my team was able to achieve no burned-in credentials on any of our systems. And we've actually been able to almost achieve that. We do have to burn in one credential. Okay? But we were able to achieve no credentials burned into any of our systems from deployment all the way through the actual microservices there. And we're lucky that we get to use AWS. So AWS's IAM is fantastic for that. So Jenkins and IAM is pretty easy, actually. So AWS recommends that any server you deploy into it have a role attached to it. This is a little outdated comment because they did just recently announce that you can now attach roles to existing servers. But as a best practice, you should always attach a role to an EC2 instance, even if that role is nothing. Okay? More importantly, because with a role on an instance of nothing, that instance can't even query its own metadata correctly in order to start exposing stuff about your environment. Okay? We attach roles to our Jenkins server. And in our case, we use CJE, so we're a big CloudBees customer. We do have to attach some roles to our Jenkins server because I don't know who knows about CJE, but it does a bunch of auto-scaling in AWS, so we have to provide it to them. But those roles are very limited in what they can do. They only need what they can do. And then they only happen within the account that our build system runs in. Okay? But what those roles then allow us to do is we can then leverage cross-account roles. Okay? And we can assume roles across account and be able to do stuff in our other accounts. And so we can make these deliberate measures or deliberate actions to leverage these roles. And in these roles, we minimize permissions that Jenkins do. So as Jenkins assumes this role, it can only do said action that role allows. And so in that, we've been able to achieve through some tooling, minimizing who can do what. Okay? Why do this? Why go through all this trouble to do all this assumed role stuff? Has anybody done assumed roles in AWS? Has anybody done cross-account assumed roles? So they're not exactly the most straightforward to set up at times. They tend to be a little bit harder to troubleshoot. So they are a little bit of work to do. It requires some forethought. But why? The big thing is it auto-rotates API keys, right? When you request keys from Amazon using the assume role, it rotates those keys. So this is where we're able to achieve no burn-in of keys, and we get auto-rotation for free. Okay? That methodology for requesting those keys is pretty well documented in Amazon's land, pretty well secured, and able to do that. The other big thing is leveraging the API in this sort. We add more tracking. So those of you who use Amazon, we have CloudTrail. CloudTrail will track both the request to gain access to the keys and then also what those requested keys actually perform within the environment. So if you're fancy and you have Lambda actions monitoring CloudWatch events, you can get into this nice automation where as things are assuming roles, at times they shouldn't be, you start blocking them and triggering alerting and so on. So it provides a nice secure model to wrap around your deployment system. Here's just kind of a diagram for those of you who don't know what STS is. So this is Amazon's Secure Token Service. But effectively, you have an instance with a role, talks to Amazon's IAM service, and I'm sorry if this gets a little too AWS-y for people. But you assume a role with rights. You then get back a temporary set of credentials. These get cached on the system. The system, next time it asks for them, says, hey, can I use these creds? If it fails, it goes through this process again. So this is kind of a single account role. You can do this within your single account, having Jenkins assume roles locally. But also, you can do this across accounts. So in our case, because we leverage all of the Amazon API, we do leverage Amazon's Container Registry. We don't actually need to distribute our containers through networking. They're all within Amazon's ecosystem. And so we're able to request those keys. Instances can pull stuff down. We can update CloudFormation templates and deploy our code. Something happens. All this code is stored in GitHub. We revert that pull request, rerun all of our stuff. It rolls it all back to the previous version. Okay? But once you get these IAM creds, you can then use said tool of choice for deployment. So CloudFormation, Terraform, Ansible, clean API, whatever you want to do, you can deploy your code. Credentials, as I said, are timed. They will expire. And more importantly, you don't just have a stagnant set of AWS credentials sitting around. Okay, and if you're lucky enough, like I am, to actually be the one that runs the security of the AWS environment and build the stuff, I just have to tell myself to rotate keys if I find them. But if you have a security team that's running and managing your IAM, if you're in a larger enterprise that has those, separation of duties, you're not getting badgered by the security team saying, hey, those keys are 90 days old. Those keys are 180 days old. You need to rotate them. Or, more importantly, having those keys get disabled for you and then blocking your stuff. You're going to be able to assume these things all the time. So, because I love CloudFormation, I'm going to show CloudFormation just to kind of give an example for everybody of IAM roles. CloudFormation delightfully last year released the YAML support, so it looks way better. Before, this was a mess of JSON that made you go cross-eyed after a few hours. But here's just a traditional YAML template. As you can see here, though, I've really minimized what Jenkins can do. So this top part of the thing is just effectively the STS command. But down here, we limit what actually policies Jenkins can do. In this, I say Jenkins, all it can do is assume STS. Right? It can only ask people for credentials. It can't actually do anything. So we're able to enable a little security by obscurity, because you have to actually know the names of things in order to access them. You can't call Amazon here and get a listing of names of things because we've forbidden Jenkins cleanly from even doing that. We can then set up an assumed role. So in this assumed role, we've set up a role for Jenkins. You see here, we've limited that role to our previous one, so that means that that server has that role attached to it. And in this case, we've only given this role the permissions to do some ECS actions. So create a cluster, create a service, and run a task. Okay? So if Jenkins assumes this role, we've limited the blast radius of what a compromised build system can do. It can only do these 3 actions. Okay? Limit that. Now, we again are lucky. We provide CloudBees. We have really tight RBAC integration into our Jenkins box. We have tooling that runs on top of our Jenkins files that checks and says what roles are being assumed at any given moment. And then based off of some requirements and guidelines based off of where the jobs ran, we limit that. So we're able to minimize who can actually assume those roles. But what does that look like in Jenkins? So here is a function to help us. And here we're just using Amazon's CLI, normal CLI. And we do a call, and we're able to assume those roles. Okay, so we do our STS call. We do a bunch of stuff against it. There's probably a more elegant way to do this. I'm not really a bash scripter. This is the way I did for this example. We're able to then parse a key, a secret, and a token. We pass that back into the Jenkins file. You leverage that in the Jenkins file and use the with environment. So the one cool thing about Amazon's API is it first checks if environmental variables are set. If they're set, it uses those to do everything. And so we're able to pass into that single step the environmental variables needed in order to do that work against the Jenkins server. So in this case, doing an S3 copy command. Okay. So again, to recap, this allows for a full separation of policies for tracking. So you're able to track who can do what. We take fine-grained permissions. So it's difficult, and it does prove to be a little frustrating, but in the end, it's more secure. I'd always rather, and I tell my developers, we'd always rather you having to always ask us to add permissions, because in production, that means you're not going to get compromised, because you only have what you need. And so we take that very deeply to heart. You can also limit this to different masters, assuming different roles. So you can lock down your production account, lock down a production master. Only that master can assume the cross roles and actually do a deployment into production, if you want to go that far. In our case, we do separate these. We have a microservices master that deploys into just our environment, our dev environments and our QA environments. Our staging and production are treated more the same, like production. And so there's a lot more limited group of people that can access those. Okay? And then these assumed roles are also accessed via the deploy scripts. So where I showed you us running Python files, the Python files actually assume the Jenkins roles also. So within the Python files, you can run Boto3's STS commands, or Golang's STS stuff, or Ruby's STS stuff and assume the roles needed to actually let the Python files do the actions that are needed. Finally, just kind of want to go over pipelines and multi-branch pipelines. Multi-branch pipelines are huge to us. We use them all over the place. And then we've used pipelines from the beginning. Again, we were lucky to get CloudBees from the start, so we had pipeline, last year, early last year, and then when it came out, we were already using pipeline, so it didn't change much for us. But every single job we do is pipeline. We don't have any single one-off builds. In fact, most of us can't remember how to do anything that's not in pipeline and not using our helper libraries because we've gotten so dependent on them. Again, pipelines provide the ability to run more complex interrelated build processes. It allows for compartmentalization of the build steps in order to identify errors. It also allows you to separate slaves for different actions. So if you go back to the AWS, you can actually have slaves spinning up with different abilities. And more importantly, it allows for parallelization very easily. And then in the multi-branch realm, it allows us to specify a single configuration and control multiple branches. And so in our case, our developers develop on personal branches and go to dev. Those all run by a dev Jenkins file. We actually version our Jenkins files to match them. When they promote their code to QA, we promote their Jenkins file to QA. Their QA jobs run against a QA Jenkins file. So on to staging and production. So we know that when we get to that production run, the Jenkins file that's actually running the build and running their deploy scripts has been tested as much as their deploy scripts and their code has been tested. And we provide that in that multi-branch methodology. Just an example of of a pipeline. Multi-branch pipeline and pipeline are the same. So in this case, it's just a single Groovy file split up into different stages. What's nice here is more than anything, it provides visibility to developers where stuff breaks, right? Did they break on a Docker build? Did they break on a unit test? Did they break, somewhere down the line? Did a deploy break? Is their code fine, but the deployment's wrong? So it allowed us to really segregate that out so that developers know where their code is at any given moment. And in that, we show green if it passes. The other nice thing about these is you can actually set kind of a status with your multi-branch. So in our development environments, we let them get through with unit tests as failing. Okay? We don't enforce unit tests in dev. We want our developers to dev fast. And so, but what we do is we mark all their builds as unstable. So in pipeline, we can mark them unstable, and it turns a nice bright yellow color for them. So they know that those are unstable. And then when they hit a more higher level environment, QA and so on, we can fail at those steps. So this is just a pipeline running a Jenkins file. Pipelines can run other pipelines, which then can run other pipelines. So we do stitch together jobs in pipeline. So here's kind of an example of that. We have a core infrastructure job that effectively goes and grabs a bunch of different pipelines to build out core infrastructure that are all individual and stitches them together for us. So pipeline can run pipeline, can run pipeline. And so it's executing these jobs. So this allows us to easily change a small piece of our infrastructure without running the full build, or when you're deploying a new environment, you can run a whole build that way. Here's an example for those who don't know of an unstable build. Here we're also bringing in the testing results into Jenkins using the normal method and bring those in so the developers can see what's happening. We also can parallelize. So I think that was the biggest thing for us. WatchGuard Cloud has data sovereignty concerns because we're storing users' data. So we actually have to deploy to different geographical regions and let that data live there. Well, we have a lot of steps that have to go out and deploy to 3 regions. Some of these steps take 10, 15 minutes. In the case of web application firewalls, it takes an hour to build those things for some reason. But we can parallelize those out. So we can build all 3 regions at once. We can build multiple steps at once. And Pipeline provides that ability. Here I also have Blue Ocean, which provides that fan-out, fan-in visibility that is really nice to look at. So you're able to see those things. So in this case, this is creating ECR repos in all 3 of our regions to deploy Docker containers to. And then finally, the multi-branch pipeline. So what's nice about the multi-branches, so this is our dev branch of one of our repos. You see everybody's personal branches are all mixed in here. One Jenkins file powers all of these builds. So they're able to iterate quickly. They come online automatically. GitHub webhooks tie in. It integrates this. It auto builds for them. So we are CI, CD through QA. We have not gotten the management to accept that through anything beyond. But we are CI, CD through QA. And so in that, we have full integration. So our goal is to always make it so a developer commits their code, and within a few minutes, that code is up and running in a place where they can access it, and it's available to the resources that are needed for it in the case of the AWS ecosystem, or if you're using Azure or any other type of cloud product. Okay. So that's kind of all I had. I hope that that proves useful for people. This is just kind of a way we've done it. Like I said, we were able to really achieve a very high minimization of plugins in our environment. We don't have to update them a lot. We don't have them breaking things a lot. And you know, that's what's worked for our team. This doesn't mean that it works for everybody, but you know, I hope it's useful for you. Yeah. Yeah. So our CJE is actually Mesos based. They just announced Kubernetes, which I was like, why didn't you just tell me to wait? So mine's all on Mesos. But yes, I have CJE. We cut over to CJE last week. So what's nice is our executors are all auto-scaled out and build automatically. The problem is with both those systems, the way they tie into AWS, they don't support cross-account. So we still have to leverage our slave build because we build our slave in another account than the one that actually Jenkins lives in. Because we have one account that our build team manages in AWS that our tooling lives in, and it's a limited access account, limited permission account, in order to circumvent security risks. But yeah, we use CJE. It's a fantastic product if you can afford it. I mean, it's fast. We build stuff significantly faster, and to be able to use those resources. Yeah. We started all this before that came out, right? We looked into it. So the problem with CJE is, it is a bit pricey, and it's fantastic, but it does cost money. And so as part of a due diligence during that, we tried everything. The problem with all of those build systems out there, you look at GoCD, the AWS CodeStar tools, you look at Distelli or any of those types of deployment products, they fit you into the way they do things. And the problem is we didn't want to do it that way, and we don't really want to do it the way Code Deploy does it, and so we leverage our own. We were able to achieve the IAM segregation, which is a big draw to Code Deploy, but we've already got that because of knowledge that we had in AWS work that my team has done. Yeah, you can do that now. Again, the problem is we built this out a year ago, so our stuff is all built and already works. And so as opposed to having to pay for another pipeline and manage another pipeline and in another scripted language or style, like we just stick with what we have. It also fits with the methodology of the way we do all of our coding, because our CloudFormation templates that deploy like our slaves match the way a microservice is deployed. And so developers can help QA, QA can help developers. It makes it easier for my team to standardize all that stuff. Why we do a Docker push? So we do that because a few reasons. More specifically, we've ran into some issues with Docker caching, and in that, we've had to circumvent it. It slowed us down. The second thing is we only build our Docker containers twice. Once you hit QA, which is the other time that command runs, it no longer gets built, right? It gets promoted from that point forward. And so because of that, we make sure that we've built it once at their personal branch and it works. We've built it once at dev and we confirm that that Docker file works. We build it that last time at QA and we confirm that it works. And then from there, it's tested in the same code all the way through. So it's more just fits with how we've broken down our methodology. Sorry, I didn't hear that. Yeah, so we actually track all our versions by QA build ID. So we carry that QA build ID through the whole system, since that is the last place that's built, and that'll dictate the version ID. So what's kind of weird is our application doesn't version +1 every version. We could go to +5 or +10 or +2. So we track it from that QA build all the way back through to GitHub. We kind of keep GitHub as our source of truth, and so a lot of our stuff tracks all the way back to what's going on inside of GitHub. Yeah. I just found out about it. I want to move to Kubernetes. Yeah. So, okay, I'm getting told that my time is up, so I'll be around if you have any questions, but thanks for coming.